Hi everyone, I'm shooting this short video to help supplement what's in the lab manual already. It's going to complement what we have written down as how to use Microsoft Excel and just show you what you can do for this last lab, hopefully to save you a lot of time because doing all of these graphs from scratch by hand would be quite time intensive. So this would just be copied verbatim from your book. This is table A. These are your values that you would have collected in lab already. And this is what we have to graph initially. So it's as easy. This is 2011 for Mac, which is probably similar to 2010 that the lab manual references. 2013 or 2014 would be a little bit different, but overall I think it's pretty similar. Here, all you have to do to graph this data is highlight the data, find the chart section, and then make a scatter plot. You want to choose a scatter plot over a line graph. It doesn't make as much of a difference here because all your time points are equidistant, but if you didn't have a linear x-axis, your line graph wouldn't give you the right results. So by having a scatter plot, you really get to see the correct relationship over linear time. And you can see here that it makes for us automatically our four groups. We have the 0.1 mil, 0.2, 3, and 4. And this is the data in graphical form. You can make it harder on yourself if you want to by constructing the graph one group at a time. I don't know why you would want to do this, but maybe the graph doesn't show up nicely like it did for me right there. So here I can make a scatter plot of just one group. This is my 0.1 mil data, time on the x-axis and absorbance on the y. If I want to add to this so I get all four groups on one graph, I click Select Data. I add a second group. I'll name it, so I'll add the 2 mil data here. The x values, again, are time. They share this data. And then the y values are my absorbance readings for that group. So you can see I've added that second group to this graph. And I would do the same thing for the third and the fourth. Overall, you end up with a graph that shows you absorbance over time for all four groups. That's the first part of part A. Now, what we're concerned about is the slope. The slope is what describes the enzymatic rate. We don't care so much that absorbance goes up, but we want to know how fast it goes up. And so to calculate the slope, what you can do is add a trend line and then display the equation on the chart. That's one option. So you can right-click on a set of data, find the Add Trend Line option. It will add a trend line for you. You'll see a window pop up, something like this, that gives you options. Linear, trend line, logarithmic. We want to stick with linear. In the options section, we might opt to show the equation, and maybe the r-squared value if we're concerned about how significant, how tight the relationship is. We'll leave that off for now, though. So the equation on the chart gives us y equals mx plus b, the equation of a line. M is our slope, which is 0.0153. So we could manually write that down, and then we can graph the slope with increasing enzyme content. Or what we can do is make this a usable form. Instead of copying and typing the number in by hand, instead we can calculate the slope and then have it in a cell that we can highlight and use in a subsequent chart. So there's a function called slope. All you have to do to access that function is equal sign, type in the word slope, open up a bracket, and it asks you now for the known y values and known x values. We're first focusing on the y values. So I want the slope from my 0.1 mil data. My y values are here. I type in a comma to move to the next group, the x values. My x values are time. You can hit enter or close the brackets and hit enter. It is really up to you. This gives us our slope. This is the actual value of our slope. And if we make the the decimal places match what we have on the chart, you can see we get the same value, 0.0153. We want to do this for all of the runs, all of the trials. We can just drag it across. But you're going to notice the numbers don't quite work. And the reason that they don't quite work is that we're moving the wrong references with each of these formulas. See here, we're referencing the y values for our data, and then the x values, which are time. All of these trials will have, they'll share time. They'll have to reference these cells over here. In the second group, you can see that we're moving both of these boxes to the right. We're not anchoring to time on the far left. The way that we get around that, well, we can go through and manually move each one, or we can simply add a $sign before the value that we don't want to change. We want this A value, column A, to stay the same. So we add a $sign here. That makes the A value unchangeable when we copy this formula. And we have to do the same thing with this A value here. So the column A will always be the same. Notice the value is different. And if I drag it across, these numbers change. If I go all the way to the end, I'm still referencing my time column, and now I have this new 0.4 mil trial data for my y-axis. So, why is this important? This is important because I want to know how enzymatic rate changes with the amount of enzyme available. How do I do that? How do I look at that? Well, I graph it. Here I can highlight, this is my rate or slope data, just so I can remember it. I'm going to highlight this data. This is going to be my y-axis, my y values. And this is a function of the amount of enzyme that we have. 0.1 mil, 0.2, 0.3, and 0.4. So if I highlight the data that I want to graph, I can go back to charts, click scatter, look for a scatter graph, just a scatter plot. Notice that I have a nice increasing linear trend. Your data might not look like this, and that's okay. Work with what you have observed, and then just try to express that in your discussion. The numbers aren't representative of the 0.1 mils, 0.2 mils, etc., because those values are not numbers. It's text, and so it doesn't know how to register that on a scatter plot. I can go back here and just say 0.1, 0.2, 0.3, 0.4. Notice if I do that, these values at the bottom here change. You also saw as I was doing that, the legend up here changed, and that's just reflecting the values in the reference cells, the name cells that I had already laid out. And we can do the same kind of operation here. I can look and see how the reaction rate changes with the amount of enzyme. I would add a trend line. I have this option dialog box pop up again. I might want to add the equation. This allows me to predict or calculate what the enzyme rate might be on the far left if I add a certain amount of it. If this is linear and if this holds true above and below the range that I've shown here, I can predict what the enzyme rate might be by plugging the values into this equation. Of course, when you want to put this into a lab report, you'll want to make it look nice. You might not want to include the equation here. You might want to add some titles. So if I go to my chart layout area, I can click on axis titles. My horizontal x-axis, I'll add a title. This is simply time in minutes. You might also want to add a vertical title. This is absorbance. The absorbance units we're not going to concern ourselves with. We're just going to say absorbance units. So this is absorbance. And then I can take this and I can put it right into my report. I can take my table data and put it into my report too. This is where it really saves time doing this in Excel. So if I take this data and copy it, And let's say that I'm working on my lab 8, my tyrosinase lab. I have my results section where I'm adding table 1, absorbance readings over 3 minutes with increasing tyrosinase concentrations. I can simply paste in my data. This is the table that you would have had in your lab report with the results that you collected. You can make it look more like a table. I can highlight, or I can add in all the borders. The same thing happens for my charts too. I can just click on the chart, I can copy the chart, go back over here, paste my chart in where it says figure 1, change in absorbance over time with increasing enzyme contents. Easy. Now you can edit this while it's in your document as well. Say I didn't want this trend line here. I can click on the trend line, just hit delete, and notice it changes the graph that is in my lab report. It doesn't change the graph back here in the Excel file. I can still change this information and then copy it back over if I have to. One of the things that I'll want to include is this data, the enzyme rate with increasing contents. Simply paste that in. It moved it to the next page, that's okay. The legend doesn't tell me too much here, nor does the equation. So I might just leave it like this. Of course I can go in and I can add titles, chart layout. I'd want to do that to make it look really good. And then it's just a matter of filling in your discussion, the rest of the questions in this Word document. You can print it, you can save it as a PDF, whatever you want to do. This will really help facilitate handing this in and transferring the data from your lab book into graphical form and then putting it in a Word document. So if you have any questions, let me know. Otherwise, best of luck.